it's Mrs. Lindquist. So today we're going to talk about the concept of radians. So we're first going to define what a central angle is. A central angle is an angle with its vertex at the center of the circle. So this little angle here swept out, this is a central angle from the center of the circle. An intercepted arc is a piece of the circumference cut off by the rays of the central angle. So here we have an initial ray and a terminal ray, and this arc right here is the intercepted arc. So now we're going to discuss the idea of what is a radian. A radian is a piece of the circumference equal to the length of the radius. Okay, so you can see here that the radius, we'll just call that r, this is 1 radian. So the distance from here to here is the radius. And if we were to take that same distance and curve it along this arc, it would go to this point right here. So this is 1 radian. 1 radian is about 57 degrees. So let's just write that down here. 1 radian, or radius measure, is approximately 57 degrees on your circle. So here I'm showing this is 1 radius. If I were to measure out another radius, that would put me at 2 radians. Another one would put me at 3. So how many can I get around the circle? I can see 4, 5, 6, a little bit more than 6. Half of your circle is a little bit more than 3 radius or radians. It's actually going to be pi, 3.14 radians or radius. So then all the way around the circle would be 2 pi. So let's talk about the circumference of the unit circle. If you remember from geometry, circumference is the formula 2 pi r or pi d. So pi times the diameter or 2 pi r. And again, the circumference measures the entire distance around the circle. We know that our unit circle has a radius of 1. So in this case, we're going to have 2 pi times a radius of 1 leaves us with so the circumference of the unit circle is 2 pi units. So 1 revolution, or once around the entire circle, would be 2 pi radians. Again, 2 times 3.14 is about 6.28 of those radius you could get around the circle. And we know that 1 once around the circle is equivalent to 360 degrees. So 2 pi radians and 360 degrees are equivalent angle measures. How about a half a revolution, halfway around the circle? How many radians can you fit in half of a circle? Well, half of 2 pi would be pi radians. So a little over 3 radians will get you around the circle. And we know that is equivalent to 180 degrees. So how about a quarter revolution? Well, a quarter revolution we know is going to give us 90 degrees. So basically we're taking that pi and we're splitting that in half again. So half pi, pi divided by 2 would be equivalent to a 90-degree rotation. Okay, so now we're going to label out the unit circle in radian measures. We've done this in degrees, but we are going to label this in terms of radian measures. So we know that 0 radians is right here, and half of the circle is pi radians, or pi radius that we can get around the circle. So we're going to take pi and we're going to split pi into 4 sections, so 4 pieces. So the first section from here all the way to here would be 1/4 pi, or pi divided by 4. So then the second piece would be 2 pieces out of 4, which reduces to half pi. What happens if we went not only 2, but 3 pieces out of 4? So this would be 3 pi over 4. And the next piece would be 4 pi out of 4, which is a full pi. what happens if we went one more piece? Well, that would be 5 pi out of 4. And then we have 6 pi out of 4, which reduces to 3 pi over 2. So that's 1.5 pi. The next one would be 7 pi out of 4. And then we're back to 8 pi over 4, which reduces to 2 pi. So basically we took pi and we split it into quarters. So a quarter pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, and back to 8/4 pi. So you can see all of our multiples of 45 degrees are going to have a denominator of 4 or 2. So we know that a quarter pi is equivalent to a 45-degree rotation. And a half a pi is equivalent to a 90-degree rotation, and so on. Okay, so now let's talk about splitting pi into multiples of 30. So here's 0 radians, here's pi radians, and now we're splitting half of the circle into 6 pieces. So what would be our first piece? It would be 1/6 pi, or pi over 6. The next piece would be 2 pi out of 6, which reduces to 1/3 pi. The next one would be 3 pi over 6, which reduces to 1/2 pi. And we have 4 pieces out of 6, going to reduce to 2 pi over 3. Then we have 5 pi out of 6, 6 pi out of 6 is a full pi. If we go one more piece, it's going to be 7 pi out of 6. Our next one would be 8 pi out of 6, which reduces to 4 pi out of 3. And then we have 9 pi out of 6, which is 3 pi over 2. Again, that's 1.5 pi. Then we have 10 pi out of 6, which reduces to 5 pi out of 3. And then we have 11 pi out of 6, and back to 12 pi out of 6, which is our 2 pi. So you can kind of see the pattern here. It goes pi out of 6, and then we have 1/3 pi, 1/2 pi, 2/3 pi, 5/6 pi, and so on. Again, these radian measures are equivalent to our degree measures. So this is 30 degrees, 60 degrees, and we can go around our circle. Okay, so example 1 says draw an angle in standard position, find the sine or cosine value exactly. So we've done this with degrees, now we are going to do this with radians. So cosine of 3 pi over 4. Well, 3/4 pi, where would that be on our circle? We know that this is 0 and this is pi. So 3/4 pi is less than pi, so it's going to be somewhere over here. We know that if it's 1/4 pi, this must be a multiple of 45 degrees. So this is pi over 4, 2 pi over 4, and our next piece here, this would be our 3/4 pi, so 3 pi over 4. So this is the location that we're looking for on our circle. So this is equivalent to 135 degrees. Okay, so we're going to draw our triangle down to our x-axis, and this is our reference triangle, so we know this is an angle of 45 degrees, which would make this length √2 over 2, and this length, we're going to the left, so it would be negative √2 divided by 2. If we're looking for the cosine of 3 pi over 4, the cosine is the x. So it's going to be this measure right here. So this would be a negative √2 divided by 2. So cosine is always negative in quadrant 2 because you are going to the left. So let's take a look at example B. So here we're talking about 7 pi over 6. Well, is that more or less than pi? Well, pi would be 6 pi out of 6. So 7 pi out of 6 would be right here. 1/6 of a pi more. So again, if you think about it, this was our pi out of 6, 2 pi out of 6, 3 pi out of 6, 4 pi out of 6, 5 pi out of 6, 6 pi out of 6 and 7 pi out of 6. So this is where we are going to land. This is going to be our terminal location. So we're going to draw our right triangle up to our x-axis. So it's 1/6 past pi. So we know that our reference angle here is 30 degrees. So that would make this length here 1/2, actually -1/2 since we're going down to get to this coordinate. And the x value would be our longer leg. Again, it would be negative since we are going to the left. So they're not asking us for the whole coordinate for this location, which again 7 pi over 6 is equivalent to 210 degrees. They're asking for the sine. So the sine again is going to be the y coordinate of your triangle. So sine is y, just like over here, cosine was x. The sine value would be the y value, which would be -1/2. Again, the sine is always going to be negative in quadrant 3 because you are always going down to get to any point of rotation in this quadrant. So in example C, they're talking about taking the cosine of a negative pi over 3, so a -1/3 pi. So we should know that we are going to be going actually clockwise on our circle. So we're going a -1/3 pi. So if you think about it, when we wrote out our multiples of 30 degrees, we were splitting pi into 6 pieces. So -1/3 pi is the same thing as -2 pi out of 6. So this would be -1/6 pi, and this would be -2/6 pi, which is the same thing as -1/3 pi. So another way to think about this is dividing pi into thirds. So if we know that half of this circle is pi, this would be -pi over 3, and this would be -2 pi over 3. And this would be -3 pi over 3, which is -pi. So it's another way to think of breaking pi into thirds versus into 6 pieces or 6. In any case, here's our reference triangle. And for a 30, 60, 90, our short leg is going to be a half. We're going to the right a half, and we're going down √3 over 2. And they're asking us for the cosine. So we know cosine is equivalent to our x, which would be the +1/2. So this will be equal to 1/2. And again, cosine is always going to be positive in quadrant 4. Because we're always going to be going right to get to any of these locations. Okay, so for our last example, they're asking for the sine of 3/2 pi, or 1/2 pi. So we know that we start here at 0, and half of our circle is pi. So if we go all the way around our circle, that would be 2 pi. 3/2 pi is like 1/2 pi. So that would be down here at the bottom. So this is our location for 1/2 pi. Here would be half pi. So if we go by half pi, pi, 1/2 pi, 2 pi. So we don't need a triangle for this. We're just going to draw a line down to the coordinate for 3/2. So this coordinate right here, we know our unit circle has a radius of 1. So this would be the order pair 0, -1. So they are asking for the sine of 1/2 pi or 3/2 pi. And we know that the sine is the y value. We're going down 1 to get to this coordinate. So our sine would be -1. So that is a wrap for this part of the lesson. So for part 2, we're going to be converting between radian and degrees. So I'll see you in the next video.